Hey, hi guys, welcome back. Welcome to my YouTube channel, TechTiger-Academy. I'm Ravi Malhotra, your instructor. I welcome you to this learning series, Learn Cybersecurity with Ravi Malhotra. This one is exclusively on Radware Application Delivery Controller. We are learning a product called AppDirector 1008. Okay, it's lecture number 2, and in this lecture, we will talk about some of those common terms, which we often talk, in any kind of load balancer or in any kind of application delivery solutions, right? It's important that we must go through these important things, like just as a refresher before we start using them, in a daily basis life. So let me start, guys. All right. So So this slide talks about the prerequisites for this chapter, right? So the basic prerequisite is that a candidate must have a basic computer knowledge. That's the basic that you need to have. Internet knowledge and IP addressing knowledge, right? IPv4 is must. IPv6 will be an advantage. All right. Our previous lecture on the Radware AppDirector 1008, we have just finished lecture number 1. That's the link for lecture number 1. My other trainings on my YouTube channel, you can find out that's my channel link, and you can find out the entire NGX R80.40 version CCSA course and FortiGate firewall version 6.4.3 course NSC 4. Okay, that's the link for it. All right, so let's move now. So the common terms that we'll talk about in this lecture are, these all are kind of very basics, right? So let us start with the OSI layers. Okay, OSI layer is a very preamble, is a uh, very basic concept for any networking student to have knowledge on. An OSI layers is a kind of blueprint, right? It's a logical methodology. Okay, it talks about different layers, right? And all these layers are ordered, as in like it's a set of 7 layers, right? Each layer got each layer has a distinctive name on the basis of the function that it performs. Okay, and each layer, as it has a name, right, it also has a position as well. Either you go upward to downward or you go downward to upward. Each layer has a position. So it's a set of 7 layers. Okay, if we start from bottom to up, so then this is the sequence. The most bottom layer is called the physical layer. It actually talks in bit as well as symbol and electronic signals. Number second here means the second layer. It's called the data link layer. It deals with frame. Okay, the third layer is called the network layer. It deals with packets. The fourth layer is called the transport layer. It deals with segment as well as datagram. The fifth layer, the sixth layer, and the seventh layer, right? These all are also called the upper layers, and these 3 layers are called the lower layers. They only deal with the data, right? And these are the different functions performed at each layer. Remember that, right? These layers, any layer can talk to the layer above it, or any layer can talk to the layer below it. Any layer can also talk to the corresponding layer in the receiving end as well. Okay, I would suggest you and I would request you to go through my another course, CCNA, where I have explained this OSI layer in an extensive depth. Okay, you can watch the whole lecture over there. That will be good to have. Next, let us talk about TCP. TCP, we all stand. So TCP protocol is one of the main protocol of the Internet Protocol Suite. TCP provides reliable, ordered, and error check delivery of streams of octets. It provides reliable, ordered, and error check delivery. Okay, TCP stands for transmission control protocol. So it controls the whole transmission. Okay, Major internet applications such as www, email, remote administration, and any type of file transfer, all this activity rely on TCP as a suite of protocol. SSL TLS often runs on TCP. TCP is connection oriented. Connection between client and server is established before data can be sent. That's a condition in the TCP. Three-way handshake, retransmission, and error detection adds to reliability, but it lengthens latency, right? Just because if this is a sender, this is receiver, if he sent three packets, one, two, three to him, one, two, three to him, right? So before he sends the next three packets, he needs an acknowledgement that yes, he has received these three packets. Okay. So this is called ordered, this is called three-way handshake, this is called error detection, this is called reliability. It's an advantage, it's a trade-off, right? That's an advantage you get, but at a cost of latency, right? TCP prefers reliability over time. UDP, as in other hand, prefers time over reliability. Okay, TCP employs network congestion avoidance. There are some notable vulnerabilities to TCP as well, such as denial of service, connection hijacking, TCP veto, and reset attacks. These attacks are some of the most common attacks in the TCP suite. Okay, let us do the UDP now. UDP is one of the core members of the Internet Protocol suite. UDP uses a simple connectionless. It's a connectionless communication protocol, and it provides checksums for data integrity, and it also provides port numbers for different functions. The TCP also provides port number for different functions. It has no handshaking dialogues. Okay, there is no guarantee of delivery, ordering, or duplicate protection. UDP is suitable where error checking and connection are either not necessary or are performed in the application rather. So any application running on top of UDP, take an example DNS, right? Take an example any other application which is running on top of UDP. It's the responsibility of that application to ensure the order delivery and the retransmission and all that. Time sensitive applications uses UDP such as live streaming. Okay, because dropping packets is preferable to waiting for packets delayed due to retransmission. So all these are features of UDP. UDP stands for User Datagram Protocol. User. All right. Let us talk about HTTP. HTTP stands for Hypertext Transfer Protocol. It's an application layer protocol. It's the foundation of data communications for www. HTTP functions as a request response protocol in the client server architecture model. These versions have been into existence: HTTP 1.1, HTTP 2, HTTP 3 is the proposed successor to HTTP 2. The default port for HTTP is 80, but then believe me, HTTP is a very, very wide, big protocol. There are so many different kind of response messages, get messages, request messages, headers, and all that. You need to do Wikipedia on HTTP, and you can learn more about that. This is just a refresher for you. HTTPS stands for Hypertext Transfer Protocol Secure. HTTPS is an extension of HTTP. It is used for secure communication over a computer network and is widely used. Okay. In HTTPS, the communication protocol is encrypted using TLS or formerly SSL. The protocol is therefore referred to as HTTP over TLS or HTTP over SSL. All right. This is the important concept in HTTPS, the communication protocol is encrypted using TLS, all right? The principal motivation for HTTPS are authentication of the accessed website and protection of the privacy and integrity of the exchanged data while in transit. It protects against man-in-the-middle attack and bidirectional encryption of communication between a client and server protects the communications against eavesdropping and tampering. That's the advantage that we get using HTTPS because it actually brings security and it protects the privacy and integrity of exchange data while in transit. Next topic that we will talk is SSL TLS. So TLS stands for Transport Layer Security. SSL stands for Secure Socket Layer. TLS is successor to SSL. Okay, that's very important. Both SSL and TLS are cryptographic protocols designed to provide communication security. TLS protocol aims primarily to provide privacy, data integrity between two or more computing applications. Secure TLS, connection between a client and server is private because it's a cryptographic protocol. That's a sender, that's a receiver, and any cryptography uses encryption and decryption and it has key concepts. So public private keys. Through that, the communication between them is purely private. We can say that it's tunneled, it's purely private. Nobody else can see that because these two parties only have keys to decrypt and to access data sent by the other person. The keys for this symmetric encryption are gathered uniquely for each connection. Okay, so let me go through them again, guys. TLS protocol aims primarily to provide privacy and data integrity between two or more computing applications. A secure TLS connection between a client and server is private or secure because symmetric cryptography is used to encrypt data transfer. There are two types of cryptography. One is called symmetric, other is called asymmetric. Symmetric is the one where same key is used to encrypt and decrypt. In asymmetric, where there is a pair of private and public keys is used. Okay, so this SSL TLS uses symmetric cryptography, where that means it uses the same key for encryption and decryption, and that same key is known as shared secret key. Okay, the keys for this symmetric encryption are generated uniquely. The keys are based on a shared secret that was negotiated at the start of the session. Okay, but again, you can learn more on SSL TLS on Wikipedia. That's a very interesting topic. Network load balancing, server load balancing. In computing, right, load balancing refers to the process of distributing a set of tasks over a set of resources to improve the overall processing. Load balancing techniques can optimize the response time for each task. Load balancing can be static or dynamic in nature. Static load balancing does not take into account the state. State means the health or processing capacity or maybe current connections. So in this, so main job of load balancing is to distribute. So in computing, load balancing refers to the process of distributing a set of tasks over a set of resources. So there are 5 packets and there are 5 servers. Instead of one server processes all 5 packets, a load balancing device will distribute each packet to each server. So that means what you will get the speed, because every server will process individually. So these packets will be processed faster. So this is the meaning of load balancing, is to distributing. Okay, now this distribution, the decision, right, that either to distribute traffic to this server or to this server, it can be done either statically or dynamically. Okay, statically is that it just works, every packet it throws, one to the another, one to the another. It does not consider the health of a server. It really does not consider if this server has already overloaded with so many packets and all that. It does not consider that. Whereas dynamic load balancing algorithms take into account the current load of each of the computing unit, or also called node. So once we choose the dynamic load balancing protocol, that keeps measuring, that keeps monitoring the state of each and every node. Now, what is the health of a node, right? How many connections are being handled by the node? What is the health of a node and all that? That's called the dynamic load balancing. Some of the known dynamic load balancing techniques are round robin, ratio, and least connections. Okay. Another term that we need to understand is caching. So in computing, cache is a hardware or a software component, and it stores data so that future requests for that data can be served faster. Okay. A cache hits occurs when the requested data can be found in cache, while a cache miss occurs when it cannot. Okay. So it's a cache hits and we have a cache miss, right? It's it's for serving faster. Okay. Cache hits are served by reading data from the cache, which is faster than recomputing a result or reading from a slower data store. What do you understand by slower data source? Hard disk. Hard disk is a slower data resource, right? RAM is a faster data store. The more requests that can be served from the cache, the faster the system performs. To be cost effective and for efficient use of data, cache must be relatively small, and the buffering provided by cache benefits both latency and throughput. Okay, so that's very important, guys. Let us move. Next is the data compression. The data compression is that this is a file of 100 MB actual size. I need to send this file to my friend in Germany. Okay, before I send a file, I will run some algorithms, and I will squeeze this file to be 30 MB, so that when I will transfer him, okay, it will take less time, because now instead of 100, only 30 MB of data will be done. It will take less time, it will be delivered faster, there will be less delay, there will be less latency. Okay, the process of reducing, so this process of reducing size of a data file is often referred to as data compression. Compression is useful because it reduces resources required to store and transmit data. That means now you need less CPU. Okay, you need less bandwidth, right? And you basically need less data. Instead of 100 MB, now you can just store this file, which is a compressed file. So it is actually storing, storage for you. And when you will transmit it, of course, it will take less bandwidth. Okay. Computational resources are consumed in the compression and decompression. That means when you are running algorithm to convert this 100 MB file into 30 MB, okay, some CPU, some memory is being spent, okay, in this operation. And same in the reverse operation. If you want to decompress, okay, so then you need to run the computational processes. Data compression is subject to space-time complexity trade-off. Any particular compression is either lossy or lossless. These are the two types of compression schemes. No information is lost in the lossless compression. And lossy compression reduces bits by removing unnecessary or less important information. Typically, a device that performs a compression is referred to as an encoder, and one that performs the reversal of the process, it is actually called as a decoder. I believe that's the last that's the last topic of lecture number 2. We'll talk about TCP window scale option, sizing, and throughput. The TCP window scale option is an option to increase the receiver window size allowed in TCP above its former value of 65,535 bytes. Sizing simply means that how much data can be sent from the sender to the receiver at a time. The throughput of a communication is limited by two windows: the congestion window and the receiver window. Okay, important. The congestion window tries not to exceed the capacity of the network. The receiver window tries not to exceed the capacity of the receiver to process data. The receiver may be overwhelmed by data if, for example, it is very busy. A web server, right, may have 100 clients trying to connect to it. Okay, so it may get overwhelmed at a time. Each TCP segment contains the current value of the receive window, because the window size is predefined. Okay, in Windows systems you can set that into the registry as well. Just Google around it, right, and you will see the default window size in TCP. You can even increase and decrease it, and it is going to cost you in your overall throughput. So be very careful when you do that. You should have a reason before you change the default value. So if a sender receives an acknowledgement, which acknowledges byte 4000 and specifies a receive window of 10,000 bytes, now the sender will not send packets after byte 14,000, because even if the congestion window kind of allows it, right? So this is how it works. This is how we play with the sizing. This is how we play with the window, and in return we try to elevate, and we try to accelerate the throughput, and we try to achieve the performance. I believe that's the last slide. Yeah. So that's all, guys. That is an end of lecture number 2. We are done. We have done these very basic topics, right? And I have just tried to cover them on very high level way. Okay. I will request you to just go through some kind of documentations that you prefer. I prefer Wikipedia because it gives you very broad level of knowledge about it. So that's all, guys. That end of lecture number 2. I'm just running short of subscribers. I will request all of you just to please subscribe to my YouTube channel so that you get notification of all upcoming videos. Thank you so much for watching, guys. Leave some comments, like the videos, forward it to your friends, share it with your friends. Thank you so much. Have a wonderful day to all of you. Stay safe, stay connected, and stay secure. Have a wonderful day. Bye.